Okay, so in this video clip using the NYC Flight 13 from the R for Data Science textbook, right, by Garrett Grolemund and Hadley Wickham, we're going to take a look again at Chapter 5, and in particular we're going to take a look at summarise. Okay. So summarise is an important function here, and it allows us to do some critical things that's a little bit difficult to do in a sophisticated way in a pivot table in Excel. What the group summaries permits here is a way to collapse the data frame to a single row. So for instance, if we go back to Garrett Grolemund's video clip on YouTube, he sets out the summarize function here. So basically he illustrates the idea. So let's say, for instance, we had data set for pollution and we wanted to summarize the values we have here to a median and a variance. So basically we're aggregating, or we're taking this data here and we're redefining it in terms of the median, in terms of the variance. These are single values. Now we also have here something I need to explain, the pipe operation. So it's kind of saying take the data set and then this pipe operation means, and then summarize the median value we have for amount, and then the variance we're going to call the var. Var is a function available in RStudio or R code, and we take the amount. Okay, so let's go back to R for Data Science, Chapter 5, and we'll look at the summarize here, and we say summarize the flights and take the mean value for the departure and the NA, the not available values, we should remove, okay, as being true. So just on the, relating to the values that are available. So there may be some values in the column that are not available, so remove those, just take the mean of those. Okay, so let's go back into RStudio, run that piece of code. So summarize the flights from the departure delay column. So let's just run that, and the average delay we're calling delay, the departure delay is 12.6 minutes. Okay, so we would like also maybe to know what the standard deviation is. So SD, we might run, do we know what standard SD is? SD, so question mark SD gives us some help here in terms of how the definition here for standard deviation. And we would like to get the standard deviation of the departure delay and then summarize it as delay. And in a sense, what we're doing here is we're taking all the variables, the 336,000 values here for the departure delay, and summarizing it to standard deviation of delay. So let's run that again, or run it for the first time here, and we have 40.2 minutes variation, standard deviation. So a lot of variability here in terms of the delay, departure delay. To explore the relationship between the distance and the average delay for each location, again we can use summarize again. This is an aggregation, but we include here this function group by, or this verb available in the dplyr package group by. And again, if we go back to R for Data Science and we go to Garrett Grolemund's video clip, Data Manipulation Tools, dplyr Part 3, intro to grammar of data manipulation with R. And we can see here how summarise aggregates the data. Also some useful functions for summary. So we in standard base R, of course, min, max, mean, median, sum, variance, standard deviation. But also in the dplyr package, there's functions for first, last, and end distinct, and so on. If we go on a little bit, we can see how summary works in the sense of aggregation. You start out with a large set of values and you can summarize to sum or mean or standard deviation. We've already seen a range. Select. So we want to see group by. Okay, so it's just a little bit past mutate. So okay, again, what we have here is we have variables. If we want to summarize into mean and sum, and then we can do that here. The mean of the amount is 42, the sum is 252, and the number of observations is 6. And again, this is a way of summarizing. And again, we want to see group by in conjunction with summarize. So one of the things we can do here is when we apply this group by, it allows us to, within our data, to aggregate. So for instance, we're looking at New York. We want to look at those together, London and Beijing. Okay, and the group by allows us to take that on board. So we can categorize. So we can categorize our data by groups. In other words, it's not terribly useful just to look at maybe the mean of the total amount, or the number of the total amount, or the number of observations, or the variance or standard deviation. Perhaps we want to see it by category. Group by allows us to break that down to establish these values for mean, standard deviation, maximum, minimum by particular categories. Okay, if we go back to our R for Data Science, Chapter 5, and we come down here to summarize, grouped, summarize. So the key verb is summarize, okay, for getting variables. But we would like to group by. So what does that allow us? Summarize is not terribly useful unless we pair it with group by. This changes the unit of analysis from the complete data set to individual groups. So again, we can break it down per category. Then when you use the dplyr verbs in a group data frame, they will be automatically applied by group. For example, if we applied exactly the same code to the data frame grouped by date, we would get the average delay per date. Okay, so we're getting, when we group by the year, month and day, we get the average, not a single value then, but we get 365 values because we've grouped it by year, month and day. Now that again is very useful. Not terribly easy to set up in Excel. In the RStudio environment, okay, we can perform that estimation by taking the code again. Okay, so let's just include that snippet of code again. I'll go back into R for Data Science, and we can just run this one. So by day, so we want to get the average delay, the mean level of the delay, not for the whole year, but by day. So go into RStudio and paste in, paste, perhaps here, paste. Okay, and let's run and summarize. And of course now what we have is the delay, and again it's the mean level of delay, mean for each day, January 1st, January 2nd, January 3rd, 4th, and that's 10 values, and for an additional 355, so 365 days in the year. Okay, so this was by day. We might like to investigate this for destination. Look at the average delay by destination. So we group by the flights and take by destination. So we define what the by destination means, and then we pass then by summarizing the values, summarize by destination count. So we pull out the number of destinations, and then we estimate the mean distance and the mean level of arrival delay for each of those destinations. So we group by destination, and then we attribute then summarize by destination. So we execute, and then delay, which we have here. And the delay figures is we have, I presume, Albuquerque, don't recognize BTV. These are the name of the airports that we fly to. Actually, we can bring that up in a second. But these are the number of flights to these destinations, and then the distance involved, and then if we go back, we can see we have the mean level of delay. Now, the reason why we take the mean of the distance is because there was 3 airports, New York, LaGuardia, JFK in the dataset. So the New York NYC flights, 13 flights originated in 3 airports, so we're taking the mean distance. Otherwise, just distance will be fine. But we take the mean distance, and then we take the mean delay, and then when we filter down, we filter means we remove certain rows. So when we filter our data here, we exclude, we only include values where there have been 20 flights, right? And we don't include, I think, Honolulu, right? I think it's Hawaii, right? So we've removed Hawaii as the one destination, and we only include in the data here where we have flights, more than 20 flights to that particular destination in 2013. Okay, so that provides us with then delay, which we can examine. And again, for the various airports, these are the number of flights, the mean distance, and again, you'd wonder why mean distance, but because there's 3 airports involved around the New York area, and then the average delay. So Albuquerque doesn't look so bad, but then ACK here, which is a much shorter distance, has an average delay which is a bit higher. So perhaps here in the reasoning, when the flight is longer, it's possible for the plane to make up any delays. And again, for the very long flights, again ATL, perhaps it's Atlanta, that's not terribly long. This one, AUS Austin, the delay here is 6 minutes, whereas for the shorter flight of Atlanta, which is 757 miles, the average delay is 11. So there may perhaps be some relationship like this, trade-off that can be observed. Now, it just so happens that there's a ggplot that captures this. So we'll look at the ggplot here as well. Okay, so the ggplot. Okay, so we can kind of understand perhaps where we're going in terms of the outline here. But the longer distance seems to result with lower delay, and perhaps this is related to the fact that in the longer distance, there's scope to make up any delays that were different to what was expected from the schedule.